So for the delegates that are with us today, does anybody want to, just a jump ball, identify where this is that the picture is? Mind the gap, familiar with that term? Jump ball, first one to the answer, gets it?
UK Metro, London
UK
Metro.
Metro, perfect, okay. What happens if you don't mind the gap?
You fall into the gap between the train and the path.
That sounds terrible. I don't think you want to. I don't think you want to ignore that gap, right? That would be a bad thing. So what I want to talk about today is, what is the gap in the cloud? And what I mean by the gap in the cloud is that today we're talking about NGINX, and what I want to talk about is a sister technology to NGINX, which is Volterra. So if you think about, you are an NGINX web server and you're trying to kind of connect to another cloud, how do you do that? So that's kind of the problem statement that I'm going to introduce. I'm going to talk about this kind of sister companion technology, Volterra, which is part of the greater, F5 family. We're one large happy family. And then I'm going to give a specific example, right? So this might be like a real world use case where, you've successfully deployed your application into AWS and you're like, hey, this is all awesome. And then your manager comes up to you or your coworker and says, you did such a good job, Eric, that, you know what, we want you to do that in Azure too. And you're like, oh, that's no problem. But then you're like, oh, wait, that really important stuff that I need, I left that in AWS. So how am I going to get that, right? So what I'm going to be talking about with this is, again, just kind of like, how are we solving this problem for our applications? How are we kind of, filling that gap so that you don't have to fall in, right? I think we all agree that falling into things is bad. So now that we've established what the problem statement is, let's talk about how we're going to solve that. So we've established that this is the problem that we want to solve, is that we've kind of deployed in one cloud environment and we need to get into another cloud environment. And maybe it's not a cloud environment. A similar story that I've seen, and many of the delegates here probably are aware, is that as we talk about migrations to cloud, or frankly, sometimes I've also heard customers talk about migrating back from the cloud, there's always this problem of resource here, but I want to be here, and you need something to connect in between. So again, jump ball for the delegates. I guess, what are some of the traditional networking tools that you might use to connect two different networks that are in two different remote locations? I'll give you a hint. One of them starts with an I.
Equinix IBX data centers, is that?
Okay, Equinix IBX, that's a great one. Other examples that are out there, maybe something that begins with a V.
Regular VPN tunnels.
Regular VPN tunnels, very good. Site-to-site VPN, doing type of AWS Direct Connect. These are some kind of traditional ways that we can try and solve that. But what I'm going to be talking about is how we can kind of blend those two technologies and be able to manage all of that. Because if you think about this, in this kind of contrived example where I just have two clouds, that's not a big deal, right? You deploy, one express route, one direct connect, you're good to go. You do VPN, you're good to go. But when I'm talking to customers, what I find out is that they're like, Eric, we need to do that, but we need to do that 500 times. How can you help? And that's really what we want to talk about, is not just building these connections, not filling the gap, but filling the gap at scale. So to do that, what I want to talk about is just kind of a basic primer in how the technology works, and just so that we can kind of demystify what this Volterra term is that we've been referring to. So what I want to start with is just kind of the origin point of where we want to go to, because at the end of the day, we want to build a connection point from this environment that's in AWS to an environment that is in Azure. So the first part of it is we need to have an endpoint. There needs to be something that we need to connect to. Earlier, one of our delegates kind of said the idea of using a VPN. So think of this as a tunneling device, a virtual machine. This is something that lives on a network, and this is something that's kind of provisioned from the Volterra console. So what we're going to be able to do when we get to the demo portion of this is understand, there's like so many clouds, like I've lost track of them. They just keep on creating a new cloud every day. it can be very challenging to become a cloud expert to know, how do I build an AWS network? How do I build an Azure network? How do I build a Google network? That can be pretty painful. So I'll kind of explain how we can kind of abstract some of those connections. I think somebody also talked about Equinix, right? The idea that, there is, between the clouds, there are these kind of private peering points where you can kind of get an optimized path between the cloud if you make use of technologies like ExpressRoute or Direct Connect. The Volterra solution makes use of our own private network. So the idea is that if you're trying to connect from one cloud to the other, there's kind of, site-to-site VPN, you could do that over the public internet, but perhaps you want to make use of a private network. So in this case, what we can do is, if you want to connect into our global network, which is a global network, you can use the public network as transport, or as was mentioned earlier, we can also make use of Direct Connect or ExpressRoute to also build these private links. So it's a very versatile technology in terms of how do you build these private connections. And that's kind of the use case I'm focusing on for today, is the use case that, you could just kind of expose this data on the public internet, but maybe this is something that has confidential data on it. Maybe this is something you just don't want sitting out on the internet. So we'll kind of walk through how that does that. And then
I have a question. So the Volterra Global Network, would that replace the Equinix, or would you actually put your Volterra network in the Equinix data center?
So think of the Volterra Global Network, whether it's Equinix or any type of regional provider, it could be a jumping off point into a private network, or in many cases, what our customers have found is they have already built their own type of Equinix type of connections, and I could replace the use of that global network, where maybe you would have a hardware device or virtual machines running in it. And for people who are kind of familiar with the networking world, we're essentially kind of creating a hub spoke type of topology. So instead of you having to kind of connect directly from AWS to Azure, you can always go through this kind of middle point, whether it's one that we provide on kind of the Volterra hardware, or it could be one that customers choose to run on their own.
No, I don't understand another point of all this architecture. I mean, I live in Italy, and I'm checking your point of presence, and you are not in Italy. So, for example, if I am in Rome and I have to reach the Frankfurt, for example, so all the connection between my data center and Frankfurt are still in the open. So I don't have anything in the middle. And then if I want to go from my data center to South Africa, so it's not covered as well. So why should I use your technology and not, because there are a lot of parts of the network, the internet in the middle. So how do I connect from South Africa to wherever you are and me to Frankfurt to just what's the advantage there?
Yeah, how far are you from the metro or kind of your local regional railroad from your house? Are you like 10 minutes? I'm about a mile away. I'm based in the U.S. from the DC metro. But for you, how far are you?
Well, actually, I live in a small town, so I don't. But it's well connected. I mean,
it's well connected through the regional network, but unfortunately, due to where you live, it's a bit further to get to that regional edge.
Yeah,
I would say that's a good analogy for the problem statement that you've described, is that in your particular geographic region, if you're geographically close to where our POPs are, then that is going to be very efficient. But for you, kind of coming from a further location, that could be a less optimal path. That's a case, though, where it doesn't have to use our locations, right? So this could also mean that you could just say, like, from your town where you live, and if you wanted to go to the next town over, you'd probably take a bike or drive over there, right? You're going to use your own type of transport to go over there. Similarly, the Volterra solution if the optimal path isn't going through our kind of regional edge, that's what we refer to as the hub, then that would be some of those examples where we would use what's called a site mesh, so that if you did want to create an optimal path that's kind of within your geographic region, that's also possible as well. So it's not just about using that transport, but also helping you kind of manage those networks of connections. Does that kind of help explain, kind of the virtues? For me, it's kind of like the choice of whether you want to live in a city or out in the country. There's kind of different trade-offs that you want to take.
The value add, I'm having a little bit of a hard time. So is it the management ability? So I don't have to have several VPN connections to different cloud providers to utilize the Volterra global network? Is that your main value add? Because otherwise I can just build my VPN tunnels right to Azure, AWS, and Google, and I'm done.
Precisely, right? So the underlying technology, this is all well understood, but the question is, if you had to do that 5 times, 10 times, 100 times, 500 times, how practical is it to kind of do it yourself? And that's kind of where our customers have come to us for help, because they have been trying to do this on their own over time, but they've realized there are kind of limits. And one of the big kind of functions of this is that we want to be able to, not just kind of manage just that AWS connection, just that Azure connection, but be able to kind of give you that global picture of all of your connections to be able to manage. So a really good, insightful comment there, Nico. Thank you. All right. So the picture changes because once we've kind of built this connection, then we can use this as the path, right? So, we're following kind of a transit analogy right now. So I'd say if we are following that transit analogy, if I need to go from the AWS environment to the Azure environment, I would take my rideshare over to the metro. I take my optimized path, taking the metro down into downtown DC, because that's kind of where I want to go. I get out and walk. So it's kind of a similar path to here for what we look at for this application traffic. Is if your NGINX web server needs to access that S3 bucket and it's living in Azure, actually the picture is a little bit reversed here, but the traffic flow we would go is, if this is what I want to get to at the end of the day, the path I'm going to follow is I'm going to connect to the node that lives in Azure. I'm going to make use of our global network here, or to the earlier point, if that's not the optimal path, we can actually kind of peer directly between these two devices. So that's absolutely an option as well. And all of those connections are being managed for you. And then you're going to be able to kind of reach that endpoint. So again, I'm going to kind of, pause for a question for our delegates, which is, if you're doing this kind of through kind of traditional IPSEC tunnel or even using express routes, what are some of the networking limitations that you might be faced with in terms of what the network ranges are? What might be some of the challenges you might hit if the networks were the same?
Can I flip that around? So if I'm using Direct Connect, or if I'm using cloud managed VPN, I have the availability and the scalability of those functions are now handled by the cloud provider. By making use of your solution, I assume this is a virtual appliance deployed in a number of VPCs across availability zones. How do you provide that same level of availability and performance to customers versus using some of the native cloud constructs?
In terms of the management, so Adam, to your point, the goal of the platform is that we don't want you to be managing these individual devices. The goal is that all of this is being done through an automated workflow. So the life cycle of these endpoints are being managed by a centralized controller. So from an operations standpoint, what you could think of this as is, if you do have this AWS and this Azure environment, you would delegate control to the Volterra platform. And then at that point, Volterra, it has the brains, it has the understanding of how AWS works. It has the brains and the understanding of how Azure works. So at this point, the Volterra platform is going to be responsible for making those API calls to both kind of check on the health of our own platform, which is a device that's running in the cloud, as well as kind of be able to orchestrate the particular cloud provider's platform as well. So you can kind of think of this as a SaaS offering of being able to kind of manage these tunneled endpoints, but have a consistent endpoint in each of the clouds. So instead of having to kind of, stitch together to the peculiarities of AWS and Azure, this is going to be kind of consistent between the two. And hopefully that kind of starts to kind of get into that question.
So you were eventually going to get to, this is a managed service for connecting your various cloud locations together, and you were, in your previous question, you were foreshadowing that this doesn't require full routing. Can you head into that direction, please?
Thank you for keeping me honest there. You guys are great. So there are two modes that we can kind of connect between the clouds. And I think this is also something that's kind of unique because I think many people have been making the point, this doesn't seem like rocket science, right? It's like you stand up a tunnel, you connect it, you're good to go. But there's kind of limits to that. And the other side of it that we haven't really talked about is the other solution is you just drop like an NGINX, a reverse proxy, you talk over public IP, and you're kind of good to go, right? That can kind of also solve the problem as well. I think what's really unique about Volterra is we converge these two approaches. So we can give our customers the choice of what's best for the applications. Because we're talking about enterprise, we're talking about cloud. In some cases, you may not have the luxury of changing the IPs that an application is using or changing, it's kind of fixed on the application side. So you have to kind of go down this routed path. On the other side of it, if you go down the proxy path of it, this is very good because you don't have to worry about, overlapping IP space and kind of creating tunnels, but you run into a next problem, which is just kind of like, well, how do I build this proxied resource so I can have it and then be able to kind of update the application. So that's kind of where Volterra can kind of handle both of these use cases. So what it is able to do is it can manage kind of the routing connection of just kind of building up that tunnel and give you the option of, do you want to kind of have these networks completely connected together? Or we can help you with the proxied configuration of perhaps you don't want to the option of being able to access the resources. Really, you just want to say, Azure, I don't really trust you. The only resource in my AWS network that you get to is this S3 bucket, nothing else. That RDS database, that Lambda function, all those other things, stay away from that. The only endpoint that I'm going to expose is going to be this proxied resource. So hopefully that kind of Alistair kind of gets into your kind of foreshadowing question of kind of the some of the differences in approach of how we can think about connecting and bringing them under kind of one consistent umbrella.
Yeah, it kind of feels like the proxy is like PrivateLink, but from cloud to cloud. And in the examples you've talked about, just Azure and AWS, are other public cloud platforms also supported?
Yeah, the PrivateLink question was a very good foreshadowing. So one of the ways that I think about this, and I'll do a brief demo of this, is just to kind of show you, from my perspective, for people who may not be familiar with the term that Alistair just gave, within a cloud provider, there is an idea that if you have two different networks and there's a resource that you want to access in one network, that you can essentially expose a virtual network interface in the other network. And that's very powerful because if you think about that, then that means you don't have to worry about, are they in different networks and routing? You just say, hey, here's the particular service I want, and I want to be able to expose it. What I think is very interesting about Volterra is that it can kind of help you in some of the cases where you want to do this across the different cloud, right? Because AWS, they have their PrivateLink. Azure, they have a similarly named PrivateLink solution, but there isn't a native way that I can expose an AWS PrivateLink in an Azure VNET. So that's kind of the use case that I wanted to explore with you today, is just kind of, how do you actually do that if you're going across cloud? So to kind of just wrap this up, let's just kind of take a look at the basic building blocks of what I was talking about earlier. So the first kind of point that I made earlier is that we can kind of demystify how you build a connection into a network. So if I'm trying to connect into an AWS environment, I could build a new network, or if you've already deployed a network, I can kind of connect into it. So that's kind of the first part. Is if we go back to the diagram, this is just where I'm deploying a virtual machine in the network, and it's giving it a place on the network, and that's all being automated, and the life cycle of that device is now all being managed through here as well. So, you know, if there's a point where I realize that device needs to be updated, I can also manage the life cycle of that device from the centralized controller. So I don't have to go into AWS to update this device. I can just make the updates from here.
And this device is inside my AWS account, providing the connectivity back to the Volterra Central. This isn't about updating all of my EC2 instances.
Correct. So we've delegated permissions so that this has control there. And in terms of permissions, you have the option of delegating that directly to Volterra. So we would have the credential necessary to make those updates, or you can download the Terraform parameter. So if you're familiar with Terraform, it's a methodology that you could run that same type of automation locally to kind of stand up the devices, but then the lifecycle and connection would still be managed as there as well. In interest of time, I'll skip over to Azure side, but I promise you that looks very similar. So once
now,
you've kind of go ahead.
How is the sizing of those devices that are deployed? Is that determined? Since that's the amount of compute that is needed to determine the amount of throughput.
Just to kind of restate the question, it was a question about sizing and what type of parameters you would have there. Some basic sizing would be, you know, do you want this to be a single device or high availability? If it's high availability, it'll be a minimum of 3 nodes. In terms of throughput in CPU, there would obviously be some guidance of, you know, depending upon the type of workload that you're trying to, you know, do with this solution, that would impact the sizing. And through the UI, there are choices for choosing the instance size so that you can right size that for your environment as well. So once that's all stood up, then we can kind of look at the next part of it, which is kind of managing the network. So from that perspective, you can kind of control all the information about building your network. So the way that we can think about this is, you know, for people who have a networking background, you can kind of create an isolated network segment, and that can be kind of handled here. For the application folks who want to take a more application-oriented way, we can manage that as an application resource. So we can think of this as a load balancer that can work across clouds. So, you know, traditionally, if you deploy an AWS network load balancer, you can only load balance to resources that are in AWS, and vice versa. If you're in an Azure environment and you deploy an Azure load balancer, you can only access resources that are in Azure. In our case, it's kind of fun. I can do things like I could say, you know, hey, my end goal is I want to create a load balancer, but where I want it to live is I want it to live in Azure. So this is kind of the first part of it. Is this is kind of, you know, for people who have done load balancing, this is kind of what we call the VIP, right? So this is kind of who I'm going to be talking to. On the other side of it, I could say, you know, the target of that, where I want to talk to, is going to live in AWS. So I can say that, you know, this is going to be, and actually I'll just show you the configuration right here just so you can kind of see that. This is the private endpoint. So people who are familiar with AWS, this is how I'm accessing the S3 bucket. And this is the site that I'm in doing. So now I've kind of built these 2 connections there. Once I have that, then the kind of final piece of it is we can kind of see all of these parts working together. So just to kind of prove that, you know, in the first case, I just want to show you that if I'm outside of Azure, just accessing it over the public internet, the connection is going to fail, because the way that I've configured this environment is I've set a AWS policy. This basically means the internet is not allowed to connect here. So this is just me showing you there's nothing up my sleeve. I really have locked this down so the internet has no access to it. So that's kind of requirement number one. The second requirement is we want to make use of AWS PrivateLink. But AWS PrivateLink, the way that it works is that it's trying to connect to this IP address that I don't have a tunneled connection to. So this is failing because I don't have a routed connection to it. And I'll kind of show you the solution in both cases. So if I hop up, I'm going to now change over. I'll just show you in AWS the expected behavior. So I'll now focus on Azure, right? So this is the case where I now want to prove to our gracious audience here that everything is all working and well. So I'm going to show you the two examples. Again, I'm just going to quiz the delegates. What were the two connection options that I talked about? One was Alistair. I'm going to call on you.
Proxied and routed were your two connection types.
Proxied and routed. Man, you guys are good. You've been listening. This is awesome. So let's look at use case one, which is doing the kind of routed method. So the routed method, what I should expect is, even though my network here is different /16 than what is in AWS, my AWS is a 10/16 for the network nerds, I should be able to just kind of copy and paste the connection from here. So let me just kind of take this private endpoint URL, copy it, pop into my Azure window, and I should be able to hit that. So that's pretty cool, right? I've built this routed connection. I've definitely done cooking show style. There's other things that I've done, but trust me, there's a way that you can build a routed connection. The next part of it is I want to show the proxied example as well. So the proxied example, it does require that you need to be able to know where I'm going to get that proxied endpoint at. So the key part here is our Volterra platform can also resolve DNS. So if I'm trying to find out, where the heck did I put that proxied resource, this is kind of where I can find a location of this is where it is. Once you have that all good and well, then I can connect to it. So for people who are diehard curl fans, all I'm really doing here is saying curl, ignore DNS, instead go to this IP address, just kind of emulate the behavior that I want. So in this case, this is a different proxied connection. And just to kind of prove that it's going through the proxied connection, the last part I'll show is that we can also provide details of the connections when we are going through the proxied resources. So from a security perspective, you want to know, like, oh, somebody from Azure is connecting in. I wonder which client that's coming in. What we can show in the traffic logs is that you can see here is the actual endpoint that's coming in, right? Because again, this is kind of coming from a proxied resource, so we can be able to track the entire life cycle of the connection. So, hopefully this has been kind of illustrative of, I've got this problem where I've deployed my NGINX resource in one cloud. There's something I need in another cloud or maybe another data center. We looked at how we create that connection, the pros and cons of using a routed versus a proxied connection, and when we saw an example of this in action. So I'll open up the floor for kind of follow-up questions.
So Eric, the first one is, this is showing as an SD-WAN, essentially software-defined WAN, with some fairly nice features around the proxying. What's the support like for connectivity back to my on-premises environment as well? Because I want to unify the whole thing.
Sure. So if you're talking, so what's nice about cloud environment is I talked about how we could automate the provisioning because there's APIs for this cloud environments. But like take my home lab, for example, I've got an Intel NUC sitting on my shelf running KVM. So let's just use that as an illustration of the on-prem. We do have the ability to run as on a KVM-based hypervisor as well as VMware. It can also run bare metal. So if I wanted to kind of put in a USB boot and load the software, it would happily work as well. Once you've kind of gone through the process of bringing up the device, you can register it with our platform. And then, yes, you can kind of complete that puzzle where now you can kind of connect your on-prem with the cloud. and you can kind of get that all working and well.
Cool. Next concern was this is encouraging lots of connectivity between clouds, and most of them have egress charging. What's traffic optimization, compression? What are you going to do to help me not end up with a ridiculously high egress charge cost?
Sure. So a lot of that is going to become, so I'll give you a good example of that. Let's say we were just doing this in a purely routed mode. One of the customers I was talking to is a problem of they've got a workload that's in Singapore, but they're getting lots of transit charges because people didn't realize that they were actually hitting EMEA, right? It was kind of a long round trip. That's kind of where I would say another advantage of doing proxy type of configurations is that you can start to give some topology to where you want to send the traffic. So because the resource lives locally on the network, if I've deployed that in Singapore, I could say, hey, from a Singapore perspective, really, I just want to kind of stay within this geographic region, but maybe that local geographic region is down. Now I can send it over to EMEA as needed. So I'd say the first part of answering it about that is less about kind of traditional compression and networking, but to say that really, if we, to me, that's one of the benefits of the proxy is more fine-grained control over where the traffic is going. The other part of this that, I kind of buried the lead a little bit is all of this is based upon Kubernetes. So when we talk about, maybe you're a retailer and you're trying to deploy this solution into the store, we also foresee solutions where maybe you're deploying your NGINX web server on top of our platform in that location. And now you don't even need to make use of that connection. You can just serve that out all locally. That could be the front end for your application. So we see that as kind of helping with traffic optimization is, why go back to the data center? You're just, maybe you're just checking the inventory. We can keep that locally. We've got disk, we've got storage. So that's the other part that I would say that would differentiate from traditional SD-WAN is that we can also offer a compute aspect of it as well. Because what we find is, our customers are building these solutions that it's kind of like an SD-WAN fabric, you've got a firewall fabric, you've got a load balancer fabric. It's just like, it's a lot of stacked things. That's a lot of tunneling protocols, right? So that's why we really see some of the benefits is that we can pool all of these together, provide it as a converged platform to kind of help solve it in a more intelligent way. So you're not going into vendor XYZ, it's just the Volterra platform. My final one was around automation. Console's great, but you're talking about this at scale. What are the automation options for it? Terraform. Yeah. I have to apologize. UIs always demo well, but rest assured that under the covers, there's a full REST API that's supporting all of that. We also have a Terraform provider, so if there are functions that you want to kind of do via Terraform, it can be fully automated through that as well. Great question. And then I know maybe I'll give Enrico the last question so we can move on.
Yeah, still I'm totally struggling to understand the value of all of this. And I'm not a networking guy, so take it with, a grain of salt. But so what is the real differentiator with an SD-WAN? I saw a lot of demo of SD-WANs and they can do, a lot of magic stuff, and the cost is not that high. So how do you compare from the TCO point of view at the end of the day or whatever? What gives me, it's like an SD-WAN on a private network.
Right.
As far as I can see, but maybe.
Yeah. You've actually answered your own question, right? Which is just to say, like, if I wanted to build Volterra on my own, I'd have to get an SD-WAN solution. Oh, wait, but now I need to get this private connection. Oh, wait, but then I need a firewall. Then I need a load balancer. So I'd say that's where the real TCO comes in, is by bringing those all together, and then kind of the automation part that Alistair talked as well. And I'll be honest too, if you haven't been up to your elbows and arms in like IPSEC, BGP, MPLS, and like all the kind of stuff that network people keep in the closet so that the application people don't have to worry about it, this is amazing, because it's just like all that like brain power that you spent on all this kind of esoteric knowledge, you just flush it. It's just gone, right? So I would say that's kind of the biggest value for our customers, is we can just kind of reduce that cognitive load of just kind of how do I get these together, and also think about it in a more application-oriented way.